Hey, what's up guys, and welcome back to a new YouTube video. Today we're going to be looking at some SML coding and translating that to JavaScript and replacing loops with recursion. So before we get started, first of all, I just want to give a huge shout out to SuperDense, the sponsor of this video, and also a project I've been working on for the past year. If you guys want to check out SuperDense, it's a really cool bookmark manager app for all your browsers and devices. Check the link in the bio and use my coupon code. So these are the problems that we'll be looking at. You'll see something a little bit different today. Usually I use VS Code, but today I'll be using Emacs because we're going to be writing some SML code first. And then when we go to JavaScript, I'll switch over to VS Code. But this might give you some cool insight onto how Emacs works and the SML language. This is part of an open source course that I'm doing, so if you want more information on that, just let me know in the comments and then I'll talk a little bit about that. But this is one of the sections of the course where we had to learn SML, which is a programming language, and it is heavily based on uh, functional programming and recursion instead of loops. Or well, at least in the course that I'm doing, we're trying to do everything with recursion more than loops. So I was really interested in seeing how this will translate to my JavaScript development, because JavaScript development is what I'm doing like 12 hours a day. So it would be interesting to see if these different kinds of languages do have a carryover to my JavaScript development and improvements in my logic, and how would I approach that. So what we're going to do today is we're going to be looking at these 5 SML problems, or well, they don't need to be SML problems, but they are denoted in the SML syntax, uh, which we'll write in SML and sort of figure out together, because I haven't written these functions yet. I'll show you now. And then we'll go over to JavaScript, and I'll just write it in JavaScript the way I think I would write it. Just translate the data structures to what JavaScript understands. Let's have a look at the problem statements. We're going to write 5 functions. The one function would be called alternate, which will take a list of numbers and add them with alternating sign. For example, 1, 2, 3, 4 would be 1 minus 2 plus 3, because this is a plus in front of the 1, so it's plus 1 minus 2 plus 3 minus 4, which will give an integer of minus 2. Number 2, we'll write a function min-max, which accepts an integer list, which is basically like an array of numbers, of integers, and it would return a integer tuple. So a tuple is almost like an object where, or it's almost like a list, but it's a fixed size where it's defined as the first item in that tuple would be an integer, and this denotes that the split between them and the second item would be an integer. So this is what the syntax would look like, min max. So what it's going to do is it's going to take a non-empty list of numbers and return a pair min max of the minimum and maximum in that list. Then the third function is to write a cumulative sum, which would take an integer list, so an array of integers, and it would return an integer list. And it takes a list of numbers and returns a list of partial sums of those numbers. For example, 1, 4, 20 would be 1, 5, 25. And the thing with recursion is that it takes a little more thinking and failing, but it also makes a lot of sense when you start grasping it. I'm in no way like a recursive pro, because I've just been using loops and maps and array methods because they're there and they're simple, but I really do think I'm going to incorporate recursive functions a little bit more. So for the fourth function, we'll write a function called greeting, which takes a string, which is an option type. So options aren't really something that we can translate into JavaScript, but it's almost like a list, but it could either be none or some. And to access the value in some, we need to use a special method called val of. The last one is write a function repeat, which takes an int list, which takes 2 int lists, and then it returns an int list. So it takes 2 arrays of numbers and returns an array of numbers that, given a list of integers, and another list of non-negative integers repeats the integers in the first list according to the numbers indicated by the second list. So 1 is repeated 4 times, 2 is repeated 0 times, and 3 is repeated 3 times. Okay, so what I've done to sort of get started is in Emacs I've written a few tests. So some of them I just use from there, but I'm defining a value, which is like defining a variable, and it equals to alternate, which will be the function that we'll define. So we might as well just create a file called, let's call it SML to JS.sml. And we might as well also create that file just now, but so this is basically just importing a file which will define all these function definitions and write the logic for them. In Emacs to save, do Control X and Control S, and then it will write the file. So now what we need to do is implement these. I think we have a good idea of what the requirements are, so let me make this full screen just to be able to see it a little bit better, and then we'll create a file by doing Control X, Control F, and in this folder I'll create a new file called SML_to.js. I have SML installed on Emacs, so if I want to, let's just do a test to get it, make sure it's working. We'll just do val hello equals, I probably need to increase the size a little bit. How do you do that in Emacs? I'm not even sure. Perhaps Control C, Control X, Control X plus, yeah. So I think that should be big enough. And then we can do val hello is equal to just the string hello. And in the file execution, you can omit or keep the semicolons. So I'm going to keep them off for now, and then I'll do Control X, Control S to save, and then I'm going to open up the SML interpreter, which would be Control C, Control S, and then enter. So now you can see on the right hand side, let me just do some, if I do use and then just specify the file name called SML to JS.sml, it will show me all the defined variables, and you can see that val hello is equal to hello, which is a string, and this definition is only the call to use, or to yeah, I think it's the call to use, so we don't have to worry about that. So every time the file changes on this side, we have to restart the SML, because otherwise it's going to shadow all the functions that I've written. So I'll just close that each time and erase that. So let's get started. The first implementation is we're going to write fun alternate, which takes a list of numbers. Let's do this. Yeah, so fun alternate, and it takes a list of numbers. So let's just do list nums. Then we have to specify its type with a colon, and we have to say that this is a integer list. Then we do an equal sign and then enter. So this, now we're in the function body. So now what we want to do is we want to have a way to loop over every element in the list of numbers and return the total of alternating numbers. So there should be a way to know which index we are, and well, we don't need to know the index, but we need to know whether we've added or minused previously. So I guess we'll need a helper function. So in that case, we have a let fun helper, which basically just takes a state, and that state is a boolean. I'm not sure if I should write full bool. I guess we'll figure out when the compiler complains. So it takes a boolean, and in the body of that function, And it also would take a, yeah, so I guess if boolean, then 1, else -1. So if boolean is true, then we'll add, and if it's false, we'll subtract. Okay, so then we have to write in, and this is what happens. Now we can access the helper function. So what we need to say is if the tail, or if it's null, the tail of list nums, then we only need to return the head of list nums, and else. Okay, so a couple errors here. This one state, or this should be state instead of boolean. And also this logic, I think we need to pass into the helper function, because we need to recursively call this helper function instead of alternate, because in that case we can flip the state of the parameter. So let's first finish off this thing correctly. What we need to do is we have to pass the list, a list copy into this, I believe. List to list copy, which is an int list. And then we can remove this for now, and we'll say that if the list copy is equal to, or well, they did say it's a non-empty list, so I guess we don't have to check if it has a value. Just make sure. Takes a list of numbers and adds them with alternate sign. So I guess, yeah, I guess we could do if null list copy, then we can just return 0. Else if the state, so if state, then we should do the head of the list copy plus the helper function, which will take the tail of the list copy, and it will also take not, let's evaluate that and say not state. So this is going to flip state. So we can just do that. Let me use this a bit again. Okay, so basically what this is doing, if so we're defining this inner function helper, which takes a list copy and a state, which should start with true. Else we'll do the HD of the list copy, so the head, plus recursively the helper of the tail of list copy, and then not state again. So in this case we should minus and not plus. So now we do have a condition. If the state is positive, we'll add the helper recursively, and if it's not, yeah, so if the state is false, then we'll minus the helper. So we have to then create an in block and then just call the helper with the initial state, which would be the list of numbers, and we'll have to give it the initial state of true, and then end that function. So I'm going to save that, and then we can go back to our interpreter, and I'll just clear this out, exit out of that, and then start it again. So let's do use the what did I call this, SML to JS file .sml, which doesn't really make sense because we're not converting anything, but it's fine. We'll do that on our own behalf. And we have a syntax error, and I think the error is with the type, because when I do val hello is true, then it is only a type of bool and not boolean. So let us fix that. Get that error out of the way, XS to save, and then we can try again. So let's go out of that, and then we can create a new one, and then we have to zoom again. I'll just delete all that, and then we could say use SML underscore to js.sml, and we got another error. Okay, so I think let's look at the error again. I'm going to remove these brackets, and I'm going to spot any other syntactic errors. That's the only thing I could really see that might be an issue if I wrap those in brackets. Let's save this. Perhaps let's remove this because I've not been using semicolon, so let's remove that. To save, let's restart this one, and then let's just clear it. Zoom it back in. So now, in Emacs, if you want to do a previous command, you can do Alt P, and then it will just go back in the buffer. So if I do enter now, alright, so it seems like the function definition was accepted. It's a function which accepts an int list, and it returns a single integer. So that's what it could sort of infer from the code. So that's the correct semantics or syntax. So let's see if we do let's say alternate, or let's do val test equals alternate, and let's do an easy one. It'll accept an array, which would be 1, 2, 3, 4. So that would be +1 minus 2, which is -1, +3, which is +2, -4, which is -2. So that should be -2. And we get -4. So that isn't the correct logic. So some more work to do. I guess an issue could be here. So perhaps if it's a negative state, then instead of minusing the helper, we should do minus the head of the list copy, and then just add that. So we'll add positive if it's state, and we'll add the negative if it's not state. See what that has for us. Okay, so let's try again. Let's use. Still finds it correctly, and if we do val test, which should be -2. Nice, so we get -2. But is this just a simple case of being lucky? Let's do val test 2, and we'll do alternate, and let's make the numbers less in order, so perhaps we were just lucky in that case. Let's do 2 minus 2, which is 0, plus 3, which is 3, minus 4, which is -1. This should be -1. And there we go. It seems like it's working. As you can see, this is quite a different way of thinking. If I was to do this in JavaScript, I would simply just loop the list of numbers and modulus to the index to make sure that it is even or odd. And then if it's even, I would basically add it because 1 is odd. So all the odd numbers would be subtracted from the total, and I'd keep track of a total. And then based on that, and I guess that's what I'll do when I go into the JavaScript version. But then we'll maybe look at reduce, or just a plain function like this which uses recursion. So the interesting thing about SML is that it doesn't have a way to mutate. So there's no way in SML where you can mutate the original value. So that's why we pass in a state to let it know if it's it should flip the state, because we can't create like a global value that's like value global equal to 123 and then or 0, and then in every iteration we just say okay, but global is equal to global plus plus or something like that. There's no such way to do that in SML. So that's why you kind of have to think a little bit differently when you code like this. And I don't know if I enjoy it because I'm self-deprecating, but it feels like you learn code a little bit deeper without resorting to loops and easier things. I think once this is grasped, we could solve problems quite interestingly. So the next problem is a min-max problem, which the function accepts a list of integers and it returns a tuple of min-max. So let's try to get that, and it's called min-max. So we'll do fun min underscore max, and we'll give it a list of nums again, and this is an int list, and what it should return in the end is a tuple of the first value being a the first value would be the minimum and the second value would be a maximum. So how would I usually do this in a loop is I'll keep track of the minimum and maximum in the global state, and if the value that I'm at now is smaller than the minimum, I would change the minimum, and if it's bigger than the maximum, I would change the maximum. But in this case we don't have global and we're not looping, so we have to think about doing this recursively. So the way we could do this, let's think about it. Let's say if the list of numbers is null, we have to return a tuple. Well, technically it can't be null. I mean, it can't be empty, because then we'll just have to return something like 0, 0. But that isn't quite accurate because 0 isn't really in that. So what we would have to return is an option of none, none. But in that case, this wouldn't return the expected value of a tuple. So let's just look at the so it takes a non-empty list of numbers. So at least we know it's not empty. So we don't have to do this check. So we can remove the null check, but it could be that it only has one value. So we can say if null, the tail of the if the tail of it is null, then we should only, so the tail of list nums is null, then we should only return the head of the list nums as the min and the head of the list nums as the max, because that's the only value that there is, so that's accurate. It is the minimum and the maximum. Else, what do we want to do? So we need an inner function. So what we'll do is we'll do let fun, let's just call it bold min max, which will accept a tuple. It accepts a accepts a tuple of type int, and we'll call that the min max of type int. Let's call it the current min max. So let's call it the current min max of type tuple, which is both ints. And then in this function, what we want to do is we also need to check the current number in the list. So what we'll do is we'll accept a list copy again, So we could say that the list copy is again a list of ints, so int list, and then I wonder if it's valid syntax to put this on a new line, because it's getting kind of wide. I'm just going to shorten these variable names a little bit so that it fits on one line. So I'm just going to do CMM and LC. This is for the list copy and this is for the current min-max. And then what we want to do is we want to say that if the current list copy is null, because remember we can pass the tail in there, and if it's null then we just have to return the current min-max. So we do then current min-max. Else it's not null, we have to check if the head of the list copy is smaller than the first property, because it's min and max, so you get that by saying #1 of CMM. If that's smaller, then what we need to do is if the head of the LC is smaller than that, so that means it can't be bigger than the second one, so we'll just have to return the second one as it is currently. So we can just do then we have to return the first one, which is now the head of LC because it's smaller than, and then we can keep the second one of CMM because that would be bigger than. And then else if the head of LC is bigger than the second one of CMM, then we need to return the tuple of number 1 at CMM and the head of LC. So I guess this is pretty verbose, and also in SML you always need an else tag. So we need an else statement here, and what will happen if it's neither bigger or smaller, then we'll just return the number 1 CMM and the number 2 CMM. And that we'll do in. So we don't need this check anymore because it's being handled for us in bold min max, and we could do bold min max now, and it accepts the list nums as the first, but we're not doing any recursive calls. We have to think about this again. So we can't just return. I guess what we need to do is we have to do recursive calls in all of these. So we have to do bold min-max, and the first one would be the tail of the list copy, and the second one would be the updated value. So now we can just call the initial state, which would be bold min-max, with the list of nums, and the current min-max would be, I guess that's a problem because the current min-max is not defined. We can't just say 0, 0. We could say the head of list nums. So we're starting at the first one for the min. But I guess that's also not correct, because if the second property is smaller than the first, then this isn't valid. Let's just see if the head of that and then the head of the tail of the list nums. So the first and the second property in the list. So technically this isn't correct because we have no idea if this is smaller than that, and I guess we can do a check. So probably we should say if the head of list nums is smaller than the head of the tail of list nums, then we could do Yeah, so then we do this. Else we'll do the opposite one. How do I copy? Edit, copy, which is complicated button, and I know how to paste, I think. Let's see. There we go. Okay, so now we have to switch these around. So the head of the tail and the head over here. So at least we know that these values are the current, that they are in the correct order. So this is smaller than that, and this is the current known min-max. And we are starting from the beginning, so we will compare every element to the current one, which means it would get replaced. So let's end that and let's save. Alright, so we got a whole bunch of errors. This should be if null else C. This. Because this will be an expression. You need to wrap all of them. So the head of the tail of list nums, and in this one the head of the tail of list nums. Okay, let's see if that fixes the issue. No, not like that. Like this. Alright, save. Alt P. Okay, it has defined. So now all we need to do is to test if it works. So we can do val test equals the min-max of the list 1, 2, 3. So it should be 1 and 3. That's correct. 1, 2, 3, 4, 5, 6, 1 and 6. Let's do something a little bit less. So we can do 36, 4, 1, minus 1. Just have to do that correctly. 22, 101. Now let's not put the biggest at the back. We can do 1, 9. So I guess this should be minus 1 and 36. Yeah, great. So that looks like our recursive function works. Alright, so the next implementation is greeting. Create a function called greeting. What we have to do is if the name, so if name equals none, then we'll just return double. Else, which means there is a value, we could do hello there space, and this is how you concatenate with the I don't know what you call that, the caret, and then we have to add the name. So the way we get the name, we have to do val of, I believe, name, and then we could say greeting or val, or we could just probably call it, it'll probably return it, greeting with none. It worked, and we can do greeting with some and Joe. Great, so that worked. Pretty simple. So the last one is repeat. Function repeat, and it accepts 2 arrays. Anytime there's a list involved, you probably are going to do some recursion. I think we need a helper function to generate an array of numbers. So we can say let fun generate list which will accept a value, and the value would be a type of int. So that's the number that we would repeat, and it also accepts the number of times, which would be an int. And what we need to do is we need to return an array, a new array of value const onto the generate list same value, but this time times -1. So what we need to do first is check if times is equal to 0, then just return the times. Or should we return the value? I think we should return the value, and we need to check that this is 1. So if times is 1, then we need to do this for the last time and just return it the value. Else we need to say that the value needs to be const onto the list. I guess now in this case what we can do is just return an empty array, because the value in the then block should be the same type as the value in the else block. So in, and now what we want to do is say that I think we might need a new let. So we could say let val, because you can also make a val equals generate list of the value which would be the head of ls1, so list1, and the tail of, we need to say that the head of ls2. So that's the amount of times, and that's the value that we need to generate. So this is the stored value of the generated list, and then we can do another in block. So now we have the stored val, and what we can do is say repeat again. So we first need to check if the ls2, so if ls2 is empty, because that means we've gone over the entire loop. If null ls2, then we need to just return an empty array, else we need to do repeat const onto stored val. This doesn't really make sense now. I guess we need to do the stored value appended to the repeat of the tail of ls1 and the tail of ls2 over here, and end it again because we have two in blocks. So the stored value at this point in time would be just this one. So let's say use, we've got an error. Inserting val, get val, stored val. Okay, let's try that again. And zoom. Ooh, everything's looking quite bad. Ah, we missed this. well, it looked like it fixed the compile error, but will it work? So let's try that. Let's call repeat with 2 arrays or 2 lists, and we'll do 1, 2, 3, and we'll also do 1, 1, 1, and exception empty. I guess in this case we should check if ls1 or ls2 is empty. Then we should just return the stored, or return the, it's just an empty array, right? Else we'll do all this stuff. So that did work, but will we execute properly? Alright, so we get a 1, 2, 3. Let's see, repeat. And I think that's one of the cool things about this kind of programming is like, sometimes it feels like you don't even know what you're doing yourself. It's just you have this idea and then you are just as surprised by your code as, you know, as anyone else that sees it. So like, I don't know if that was going to work, but it made sense, and if the test cases pass, then it works, so no problem. And I'm pretty new to it, so I guess that's just how you feel when you explore new concepts, but and we'll see how I feel about it in JavaScript. But yeah, it's a pretty cool feeling if you see stuff working out. So let's do 1, 5, 6, and then we'll repeat 1 3 times, we'll repeat 5 0 times, and we'll repeat 6 1 time. Nice, that did actually work. Alright, so back in our favorite code editor, VS Code, everybody's loved code editor. Hope this text is big enough. So first I'm just going to create a tests file just to have all the tests sort of automated. So pretty bad testing library I'm building, but it'll get the job done, I believe. At least those are defined now. So alternate will accept an array. So what we need to do is call that nums, and what it should do is add numbers in alternate. So what I would do is I would do nums dot reduce, and that accepts a current value or previous value, current value, and the index. And I think we need the index. And then I'll return an so we'll start at 0 because that would be the first previous index, and then what we'll do is we'll say if index modulus 2 is equal to 0, which means it's divisible by 2 exactly, which means it is a even number, then we should return the previous value plus the current value. Else in this case we need to return the previous value minus the current value. Min-max. So the synopsis of this function is to take an array and return the minimum and maximum as a tuple, but in this case we'll do the an array of 2 elements. So let's say nums again, and in this case we want to, so a quick way I'll do this, I'll just say let min, so this is JavaScript, we just let it rip with undefined values. So we can just do that. We don't know what that is now. So now what we can do is just say nums dot for each num, if the num is smaller than the min, then min would be num, else if num is bigger than the max would be the num. Or if there's no min, so or if no min, or if no max. I guess we have to be more explicit and say, or type of min is not equal to, or type of min is equal to undefined. Then we'll set the min, we'll set the max, and in the end we'll return a new min max. It works. We'll refactor these at a later point. So for greeting we have a name, and if type of, or we could just do return type of name equals undefined question mark, and we could even do this. We could say hello there, comma, and then in that comma we have to either say you or a name, and that we'll do in this block. So if it's undefined we'll say you, and if it's not we'll say name, and we have to add an exclamation point. And then finally repeat. So what do we want to do? We want to repeat, it accepts 2 arrays, list1 and list2, and we want to repeat the elements at the index of list1 the amount of times of the value of the number at the index of list2. So what I'm going to do is I'm going to create a for loop. So let I equals 0, and remember the specification didn't require that they have different lengths, so I'm just assuming they have the same length. So list1.length I++, and then we could just say that, you know, let's mutate some stuff. We can do a const. It's supposed to be a constant, but we can change it, which is awesome. Very great. Const final equals that. And how do you change a final array? You push to it. So now we can say that if, and we can loop again. So for each item, so for let j equals 0, j is less than list. Yeah, j is less than the list2. List2 at the index of I, and then j++. And what we want to do in this case is just final dot push the list1 at i's value. Is that it? Oh, we have to return final. Go back, uncomment these. Awesome. We got it. So that is a pretty quick implementation in JavaScript, rough, dirty implementation, and it did feel a lot faster and quite a bit easier than the SML, but I guess that's just because I'm using things that are familiar. Um, I'm allowed to use methods and I'm allowed to use global variables. I can use loops. So the so the language tools can speed up development, but what I'm trying to figure out is it safer to use recursion or to sort of restrict yourself away from all these fancy tools and things? And especially, is it safer to not mutate state outside of your scope? What's that called? SML to JS.sml. And there we go. So what did I do? I had the helper. I can close this down. I had the helper which received the list copy and it received the state. And then it checked if the list is null, then it returns 0. So I'm going to try and just exactly replicate this code in JavaScript. So if no nums copy dot length, which means it's 0 or -1, then we have to return 0. If state we have to return the nums copy at 0 plus the recursive call to alternate, to helper, and give it the, I guess what we can do is just pop this, but that would be mutating the original array. If I say nums copy.pop, or unshift, then, or shift, then this nums copy would be mutated, and that breaks one of my rules. So now we have a way to check head and tail, although not very functionally, but at least a little bit better. So now we can check if null list copy, which means it's an empty array, just return 0. Else if the state is positive or is true, then we have to return the head of nums copy with the, or added to the recursive call of helper with the tail. Increase the size a little bit, plus the tail of nums copy, and the opposite of state. Else we'll just return negative this thing. So now what we can do is call helper. We can just return that. We can return the helper with the nums, and the state initially is true. Find a different way to run these functions, but let's see. Let's do node tests.js. First one is false. It gave me 123.5. Okay, so I did a test and I think I made a mistake in the head function, because in SML the head is only the element and not the array. So I have to basically, well, I could basically, seeing as we're just returning the value, I could just do array 0 without a loop. So that's more efficient in terms of mutation and loops. And Okay, so that looks better. True, 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 true. And I just added this console log for debugging. So I guess that's a sort of SML way to do it, but we don't have intuitive ways to do tail or head in JavaScript. Head is just array at 0, but tail we sort of need to remove the head, but without affecting the original array. We can think of doing it. So if the list copy is empty, then we'll return the current min max. Else, or if the head of the copy of the list is smaller than the CMM at 0, then we have to return build min max at the tail of list copy, and we need to what are we doing? We need to get the head of the tail. Oh no, we need to pass the current min max. So the current min max would then be an array which the first element is the head of the local copy or the list copy, and the second element would be the current min max at 1. And if the head of the list copy is bigger than the CMM at 1, which is the max value, we have to do this again, but give it a new min max with the sale tail of the copy, and now with a min max of CMM at 0 is the minimum, and the maximum is the head, so head of LC. And there's another case where neither of that is true, then we need to return the build min max of tail of LC and the current tuple or 2-element array would just be the current min max. So I can just do current min max. We have our helper function, and then we need to use it, but we have to check that if the head of the nums is less, this has to be like that, oops, crossing dangerous territory into SML. So if the head of the current numbers is less than the head of the tail of the numbers, this is, I was wondering what this logic is for, but this is the check to see if the first element that we're passing in here is a valid object, because we, in our other implementation, we just defined it as undefined. So in this case we're giving it a number and a relatively accurate numbers, because we're giving it the first and second element, and whichever of those two is bigger or smaller, we're at least arranging it in the correct order, and then we know that exists in the array, so anything smaller would become min, anything bigger would become max. So if that is the case, then we need to return, so I'm just going to do this, return the build min max with the nums, and we have to give it the head of, so we need to give it an array with the head of the nums, the first one, and the head of the tail of nums as the second one. And if that's not the case, then we need to return the Boltzmann max of nums with the opposite. I'm going to copy this over here. And this one as the second argument. And it seems like it did work. So we can delete that code. And now, so repeat. So we have a list 1 and a list 2. And we need a function helper, so like generate list. And it accepts a value and it accepts a times. So how many times are we going to repeat this value? And we could say if times equals 0, return that, else we need to return. So in we have this nice operator, this cons operator in SML, which we don't have in JavaScript. So I'm just gonna use something that I think might be similar. So I don't need to say else because I'm returning, but what I can do is I can say value needs to be added to the first. So what I can do is create an array and do value and then spread the rest of the I'll just pass the value and the times -1. So that means that I'm just adding it to the front of array. So now I can use that. I can say if the list1 dot length, if there's no list1 dot length, then we have to return an empty array. Also we return, let's first create that val. So we do const stored value equals generate list with the head of list1 and the head of list2. And now we can do if list2.length is, there's no list2.length, then we just return an empty array. And I guess we could just do this here. And we might just combine this. And then we can do return the stored val. And the operator that I'm using here is a @, which basically merges two arrays. So what I need to do is wrap this in an array and do that and call that repeat function again with the tail of list1 and the tail of list2. Would have been cool if I maybe did some benchmarks. Let's first see if this works, not just assume. Alright, so that actually worked. Awesome. But it would have been cool if I did a benchmark like so we can do console.timelog.time recursive, and then console.time end recursive. Now we can run that again. So that took 1.103 milliseconds. Wow, the second one was much faster. The first one is probably some startup time. Okay, so we're getting an average of about 0.3 milliseconds, which is really fast. I guess it's not much data, but so let's use 0.316, and then let's go back to the lib and do. Let's see if we have a difference in speed. Well, it's pretty much the same. I guess it's too small of a test to really say. Okay, so I've edited this a little bit. I think this is the correct call. You need an existing array to fill. That's a lot. 9 point. Should have probably not logged that. Let me remove the log. Otherwise, that might be taking some time. So 4.1 milliseconds, 4.3, 4.0, 4.1. So that's for 10,000 elements. Now let's go back to the recursive one. Do that again. Whoa. Whoopsie. We got some inefficient code. And that's the other thing about recursion, is if something needs to continue happening up until the end, it will keep splitting branches if you have separate conditions for that. It'll keep doing that. So I guess this is probably just very inefficient code, and I could improve that. But I would like to see if there's a recursion topic out there to see if, things improve when you use recursion, because it's very interesting and it's very fun to write, but I'm not sure if it's going to improve my JavaScript development. Certainly my SML development might be okay, but I mean, this is garbage. I've just started learning it, but in the future when I get better, recursion is a must-have. So if I can write efficient recursive code, then that might improve my JavaScript. But it's an interesting topic. I hope you guys found some value in this video. I guess it was just, catching up and doing some code together. And I wanted to let you guys know that I'm also sort of planning a next course, because I've been working on 2 commercial apps for the past year and a year and a little bit. If you think I should, maybe just give a thumbs up or leave a comment. I really want to go deep into Nuxt and start from the bottom up and sort of create a long season of tutorials, with starting from scratch up to building a huge example or something like that. And we can make it open source. But yeah, let me know what you guys think of that. Let me know if you enjoyed this kind of video. It was a bit of just playing around and catching up, but I really enjoyed it, so I hope I see you guys next time. Cheers.